Welcome back to Learning Solidity. Now in today's tutorial I'm going to be covering crowd sales, which also can be referred to commonly as ICOs. In essence they're the same thing when it comes to Solidity. Now I have had a lot of requests to actually do this, as well as a lot of requests for me to help other people with ICOs. Personally, I'm not a big fan of getting involved with ICOs, so unfortunately you will have to find someone else to help you with it. Now, today's tutorial is going to be based around the previous tutorial I did on tokens, which I'll leave in the description box down below. Now, we're starting with my token. I've actually tweaked it a few times, so this is a more clean version of the actual original token. I've also kind of packaged it up a little bit nicer inside of Truffle, and also added some deployment scripts as well as a fair amount of testing. Now testing is kind of a little bit key today. I'm going to develop the crowd sale in the approach of sort of test-driven development, where what I've already done is outlined a suite of tests that are going to have to be passed or fulfilled before we can actually obviously finish our contract essentially. Now the reason I'm doing this is because I'm not sure if you may or may not be aware of recent events with the Parity wallet. There was a small vulnerability there where a user was actually able to gain access or basically become the owner of the Parity wallet via sort of like it was basically an initialization if certain criteria of that contract hadn't been met. Now the reason I'm obviously doing it this way is to highlight the importance of testing. Now I can imagine that that Parity wallet was tested very thoroughly, but obviously when you're actually working with something that's completely immutable, testing is parallel to nothing really. It's so important to actually have a full and concrete suite of tests, because once you actually deploy your contract to the network, that's it, that's set in stone. You can't change it. Now I know I have actually come up recently with the concept of the microcontract architecture, which actually, I say permitted, it's kind of a manipulative way to actually mock mutability within the sort of Ethereum network or Solidity. I know it's actually had a bit of bad press, but you know it can happen and it does work even in the current state of the network. So I'll kind of leave that there. So we have our my token from last time. I'm not going to go into too much detail with this. The only thing that I've added, and I will go into a little bit of detail on, is the sort of the tests I've done for this. Now I've done two types of tests for this. The first is the JavaScript test. Now I did actually refer to these previously as the integration tests, and they're more end-to-end actually, rather than integration tests. Right, granted it is sort of an integration into the network and sort of interacting with them at an integrated level, but they're probably better described as an end-to-end test, where we're not segmenting any set of functionality, we're testing the whole thing as a singular unit. So I know that obviously with a unit test, obviously you take a small part of the actual application and test that as an individual unit, but as we're testing everything in one go, it's more of an end-to-end test. But you know, that's neither here nor there. So what I've done with these set of tests, I've taken these as the baseline example from the Truffle test suite, and I've just gone along the lines of doing some very basic interactions. So with my token, the first thing I did was just to ensure that 10,000 tokens were allocated to the total circulation of the token, which is basically what we can derive from the total supply call. Now there's two ways of actually calling any sort of function within Solidity from one of the test suites, and you can do that via the .call method, which returns the explicit response from the actual function itself, or you can do it by calling the function directly. Now this won't return the actual return, if that makes any sense. It will return the whole sort of transaction. So you could, if you wanted to then do something beyond that, you would then have to extract any information you wanted from the transaction. It's quite good if you wanted to, for instance, check the total gas consumption or any other sort of like criteria for that, like checking block numbers, block times, and so forth. So that is essentially two ways you can call your Solidity functions from the JavaScript testing suite. Now this sort of like layout, I can never remember. There is actually a name for it. I believe in previous development, I've always called these sort of like Jasmine tests, where you have this sort of descriptive way of writing tests. So we're stating simply that contract my token is our encapsulated environment of what we're testing. And then we're stating simply, like for instance this test, it should contain 10,000 my token in circulation. And on the assertion failures, we have the comments such as 10,000 my token are not in circulation. The English probably could do with being corrected there, but I try and keep it quite simple and quite straightforward rather than having this big elongated description that makes not much sense. This basic set of functionality, or this testing suite, all it does is check to see that 10,000 tokens are in circulation. 10,000 tokens were attributed to the creator of the token. The ability to transfer 1,000 tokens from the creator to a recipient, and then verifying that both balances were updated. The next thing would be then to check, this is kind of the ERC 20 sort of functionality standard is working, that we can delegate 500 tokens to a delegate address, and then that delegate address actually has a valid balance of 500 sort of allocated tokens. Then we test that address, that token delegation, to see if they can actually transfer 200 tokens from the original creator address to the recipient via the delegate address. Now obviously a lot more testing could go into this, but I just wanted to cover some of the basic concepts of what you could do with testing. Now with the end-to-end tests kind of covered, I'll jump into the unit tests. Now this is a very basic set of functionality, again very similar to the end-to-end tests, a lot of this functionality. There is something that I would like to highlight with the actual sort of unit test within Solidity, or sorry, should I say kind of remix. Not remix, this isn't remix store, this is Truffle. Within Truffle, where you essentially there is a bit of trouble basically testing things that are for instance payable, or using multiple addresses. Say for instance in the end-to-end test that I had here, you can specify where the actual calls are coming from. So for instance I wanted to delegate so many of the tokens to a delegate address, and then I wanted to mock the call from the delegate address, which is fine from the end-to-end test, because obviously I can specify where the call originated from. In this case it was delegate address, and obviously from the other calls I can specify it came from the creator address. But actually in the unit test that isn't something that I can do. So if you wanted to test that set of functionality, you've got to be mindful of how your tests need to be applied essentially. So there was one that I couldn't test, which in the actual set of unit tests, which was the delegation of tokens, and then the allowance sort of allowance spending of those delegated tokens. Now I couldn't mock that at all, so I had to do that in an end-to-end test, and that was something that's basically been missed out of the unit tests. So it is important, the stuff that you can't test within a unit test that you should test essentially with an end-to-end test. But I try and cover all bases by testing both essentially. The unit tests are a great way of exposing like just simple functionality isn't working the way I expect it to on a sort of like a unit level, whereas obviously the end-to-end test will kind of show their usefulness, especially when you have multiple contracts. Now with that being covered, I'm not going to go any more into this sort of this part of the testing, but I will now go and look at the Crowdsale test. Now essentially I'm going to just create a quick split on this. Let's split to the right, and let's set up the test here. Okay, so I've already defined this. Now I have actually written the code for this already, which is actually on the screen to my left here, just so I've got an example of what I was originally testing. Now I didn't actually take a test-driven a sort of test-driven development approach to this, because I didn't have a specification for this. I kind of winged it. For a test-driven development approach to actually work, you need a specification. So I now have one, but I obviously had to develop it before I kind of knew what I needed to test. So let's just sort of like break this down into some very basic things. When we're creating a crowd sale, we want to create some sort of restrictions. Now obviously a crowd sale might not have these restrictions essentially, but this would be more applicable to ICOs. This is why I'm kind of encapsulating the two together. We want to set some limits. So with an ICO or a crowd sale, we might want to limit how many of the tokens that person can buy. We also want the ability to specify how much each of these tokens will cost. Now I've made this very simplistic to actually do, and it's sort of like a very sort of like simplistic approach is I'm saying that one token is essentially one ether. I should have probably done it as one way, but it was easy just to do as one ether. And from that as well, I've also created a start and end date. Now again, essentially you might not have that in a crowd sale, but you might. It's completely subjective to what you want. I'm just trying to cover all the basics. Some people like to develop the crowd sale or ICO within the token itself. Personally, I feel that's kind of a bad practice, because say if you had several iterations of your ICO, or for instance you had a bug in the ICO and you needed to destroy it. If you found the bug in the ICO, that means you have to destroy the token as well, so you kind of lose both. Whereas obviously if you just have the bug in the ICO and the token is completely detached, it's a lot easier to destroy the ICO and then fix the token. It's a lot easier to destroy the ICO, fix it, and then redeploy the ICO again, or the crowd sale in this case. So let's just start looking at the functionality that we kind of expect the crowd sale to be able to do. Now, this first function is simply to allocate the resources to the crowd sale. So I say this function, this sort of test, and all we're testing here is that we are transferring to the crowd sale address 1,000 tokens from the creator address. So when I created the token, I want to allocate 1,000 of these tokens to the crowd sale, because that's all we're having in our crowd sale. Then we're just simply calling the balance of the actual crowd sale on the token to verify that there is 1,000 tokens associated to it, which is great. So it is. This could also be done in a way of delegation. Now, actually just sitting here thinking that through as I was describing the issues that might have cropped up with an ICO, delegation is probably the better approach for this, but I am just going to show you the transfer of, because I've already written the test for it. And obviously if you do that whole sort of delegation process, if the ICO is broken or faulty or so forth, you don't actually lose tokens. Whereas like I said when I was thinking that through just then, if you actually allocate those tokens to the ICO and you have to destroy the ICO, those tokens are still bound to the ICO and therefore stuck to the ICO and essentially lost. So just a mindful thing when you're actually considering doing this, make sure that you consider using the sort of like allowance rather than just sending the tokens to the actual ICO contract. But in this case, we're going to stick with that because it's the simple approach for it for now. Then the next thing I'm testing is making sure that our deployed crowd sale has an available balance of 1,000 tokens. So that's something we're going to have to define. And I'm actually going to do this kind of as we go. So we know that we need a function called available balance. Okay, so that's the first function that I'm going to create in this. So function available balance. It needs to be public. It's not going to change anything, so let's create it as a view, and we're going to have to return a event. So that's our first function that we're going to have to create, and this is kind of the TDD approach to sort of development. We're creating these constraints as we go through our tests. Okay, so we don't need any functionality there because we already know that that's what we need to call. So the next thing is going to be the ability to buy something from the crowd sale, and we're not specifying any parameters here, because if you see this object here, this is what's passed after the parameters of the function. For instance, there is another call similar to this, so down here by for, where we specify the first parameter, and that's the parameter passed to the function, whereas this is essentially the sort of constraints of the transaction. So in this case we're saying where we want to call it from and how much ether we're going to be sending to that call. So we've got our call here to buy, so now we need another function. It's going to be called buy. And as we're sending ether to it, we need to make it public, I think it's going to interact with something, so we need it visible as well as interactable. So we're not going to make it view or pure or so forth. We're just going to leave it as is. We're going to state it's payable, and let's payable, all right. And then we're simply just going to state that it actually doesn't have any return. So we'll kind of leave that there. Obviously, we're going to add more functionality to this as we go along, and obviously add more modifiers and so forth, but for now we'll just leave it as it is. The next thing obviously was the next function call we're going to make, which is the by for. So function by for, and then we're going to simply make the same again, public payable, and we also, in this case, we need to pass a parameter. Now this parameter is essentially just going to be an address, and I'm going to call it, I'm trying to remember what I called it in my original contract, a beneficiary. Let's see if I can get this spelled right. Beneficiary? Close enough. If I'm wrong, I'll correct it later. I think that's right anyway. Looks it. Either way. The next thing that we're going to have to do now is, because there's other aspects that's going to be interacting with this. Now I did leave, this was kind of more of a reminder for myself, that the Crowdsale is an ERC 223 receiving contract. Because if you remember when we originally did the ERC sort of 223 standard when we're developing contracts, it's essentially a way that if you send tokens to a contract, that they are notified that they receive that balance of the token. So let's just open the ERC 223 receiving contracts. We need this function here. So let's just simply copy and paste that. And there is our fallback function essentially for when a token is passed to that function, or when essentially a token is purchased, the contract of the token will call that function specifically. Okay, so I think we've covered all the basics of what we're going to need for the function calls. We're also going to need a couple of little other things. Because I've stated previously, we're going to have some constraints around this. We're going to have a start time, an end time. We're going to set a limit for the amount that people can purchase during the crowd sale, and we're also going to specify a price of each of the tokens. So to do this, we're going to use a constructor. So let's create a constructor, simply function crowd sale. Now let's pass our parameters in. Just checking my little example here on my left. So the first thing that we're actually going to do is state where the original token is basically located. Now obviously we kind of want to limit the ability to call this fallback, this token fallback method. We only want it to be called from the token we're doing the crowd sale for. So we don't want any other tokens and so forth to being able to interact with it, or any other contracts for that matter, or even any other addresses or any sort of level of transaction. So the first thing we're going to do is have a parameter called token, which is the original token address. The next thing we're going to have is the start. Now there's two ways you can do this. I'm going to do the block number, but you could also do the time. So obviously you can create a start and end period based off the block number, which is non-deterministic, because you don't know when the start and end block will essentially hit. Essentially the time-based one is kind of deterministic, but it can be off. So either way, it's kind of a personal preference. I'm going to go for this as the block number, just because it makes things a little bit easier for me. So uint, and we're going to say a start time. We're then going to say a uint, and we're going to have an end, which is going to be the end block number. We're then going to have a uint, which is going to be the price of each token, and we're going to have a uint, which is essentially going just to be the limit of how many of these tokens are available. So let's check the well, let's sort of create local variables for these. So we're going to need an address, which is private and is for the token. Now someone did actually mention to me like about the use of the modifiers recently in Solidity, who told me that they're not there to hide the values, and I highlighted them. I know it's nothing to do with hiding the values like any other programming language. It's an access modifier on what can manipulate those specific variables. Now, when you're actually designing a contract, it's important to actually, or any sort of software for that matter, to understand what can interact with each attribute of an object, or in this case, a contract. So using access modifiers, I always find is very important. You should never just leave them as blank or public or so forth, because you're never interpreting always what outside factors are interacting with those specific elements. And obviously, if you don't encapsulate things properly, this is where security vulnerabilities come from. So I'm actually going to create a member attribute for each of those. So we've got a uint, we're going to make it private again, we're going to say some sort of start. Now, the reason I do this is simply because having the underscore is kind of the way that I define it's a member attribute, because you can't use this dot and then like you would in, say, for instance, JavaScript or Java or so forth, or even C. Is it C or C++? I think C++ dash greater than is a reference, and dot is a member attribute or an instance attribute. Either way, it's easier just to have an underscore, just to actually just so you're aware when you're actually coding that is actually a member attribute rather than something that you've defined within the scope of a function call or so forth. So let's just assign all those. So start is equal to start, end is equal to end, price is equal to price, and limit is equal to limit. Now, if I'm right, I should now be able to actually test this. It hopefully should fail, so I'm actually just going to bring up my shell for this. Okay, I'm just going to run a test. I already have a test RPC running on the computer or the monitor next to me, so hopefully this should compile. It might not, it might have another issue, but I believe we've fulfilled all the constraints. Now the tests themselves will fail, which is kind of what we expect. So my original tokens all pass, so my test token tests all pass. So let's have a look at what's not working. Should transfer 1,000 my token to the Crowdsale balance, and that worked because it was actually functionality of my token. The next thing was should have a Crowdsale balance of 1,000. Now that did not work. Now why did that not work? So let's just see what actually caused that to fail. Should have a Crowdsale balance of 1,000. So we're actually now interacting with the Crowdsale. We're calling available balance, which is this function here, and we're expecting the return value of 1,000. Now, we're not returning anything, which is probably why this has actually happened, or why this error has been thrown. So we actually need to define somewhere a balance. So let's say private, and let's just call it available. Actually, no, let's just call this balance. And we're going to return the balance. Now, even though we're actually returning a value now, that's still going to fail because that will return 0. So because we have the fallback method here, we can simply state that when this fallback method is called with a value, we can assign underscore value to the balance. Now, this is kind of where we need to bring in safe math to ensure that things are actually added correctly. Because we're handling unsigned integers, we do not want, say for instance, negative values and so forth, or things to overflow anywhere. So let's first include the safe math library. I've already created, this is kind of a modified version that I've actually done. So if you're actually developing something, I'd consider using the original safe math library rather than this kind of modified one that I've used. I just when I was testing this, I was playing around with other sort of constraints and so forth. Safe math 4, and then a uint. Okay, so instead of balance equal value, we can now say balance equal balance dot add value. Now essentially you could manipulate the ICO here if the value was sent from someone that you did not want it to be sent from. So you could also add a constraint here to check that the from address that the balance received from is one that you want to actually receive. So for instance, like the creator of this contract is the only person who should be able to send it. We could set that constraint, but for now I think I'm going to leave it as is. So hopefully now, with that small change in place, if I now run the tests again, we shouldn't have so many failures. Now, just a side note, if you want to get rid of these warnings, because I'm not using the from or data, when you're defining functions within Solidity, you don't actually have to assign them variables. You can just simply state a data type. And if I call that now the truffle test again, we should hopefully have one less failure, or we should have at least 2 tests that pass. And let's hope for the best and hope it actually does work. Okay, we have a little less warnings this time, which is good. And as we can see, we now have 2 tests that pass rather than 5 that failed. So the next thing is should transfer 1 token to the creator address. Okay, so let's see the next test. It should have a, so no, we've already passed that one and that one worked. Should transfer 1 token to the creator address. So what it looks like we're doing here is simply buying one of the values, or one of the tokens from the Crowdsale. Now that's been done via this buy method here. So we now need the ability to actually transfer the value of that to essentially the address. Now because we actually have a reference to the token here, I'm actually just going to change that to something else. Instead of stating it's an address, I'm simply going to state it's the token. Because you can pass an address to a contract definition, but because we're defining token here, we also need to state an import for it. So an import.token.sol. Now you might be wondering here why I'm specifying token instead of my token, because token is more of a set of constraints rather than an actual whole implementation. And it allows the ability to sort of reuse this Crowdsale for other tokens that follow or adhere to those sort of standards. So because we're transferring 1 token from our address here, or our Crowdsale here, to another address, we can simply state that token dot, and I believe we need to check the token. I think it's just the transfer, token dot transfer, and then because we're sending it to the person who's buying it, message dot sender. And we're simply going to send the value of 1. Now this is a kind of a little cheat way to pass the test, because we just want to see that the test passed, and then we'll improve the code from there. But we're also subtracting the value of the balance as well. So balance is equal to the underscore balance, and then let's say sub 1. I think it's sub 1. Now let's give that another try. Now hopefully this should make a 3rd test pass, but we want to improve this a little bit more because we've kind of cheated a little bit with this one. So let's just, we forgot to define that as a token. So now let's get that compiled. Now hopefully we should only have 3 tests that fail. But like I said, we kind of need to improve that a little bit better, because we're kind of missing a lot of things with this. We're just assuming that the balance that was sent was 1, and also that we're basically only going to subtract 1. So okay, now we only actually have 2 that failed because that fulfilled 2 of the actual tests. Okay, so let's fix a few little things here. Now when I say fix, what I really mean by it is improve. Now because the functionality of buy and buy for are very similar, I'm actually going to move the buy for functionality down here, change the beneficiary to that address, and then simply state buy for message.sender. Now hopefully that should cause all of the tests to pass. So we should have a complete, fully working set of tests. Let's see if this works. We still have one defaulting to public. Right, so all the tests now pass, which is great. Let's have a look at first things first. Let's clean up some of these warnings. So that was moaning that that's not public, so let's make that public. The next thing is that we have no real constraints on buy or buy for. A lot of people also want the ability, just if someone sends something to this specific contract, that the contract itself has a fallback mechanism in place to catch any transactions being sent to this contract and have the ability to process them. Now, I actually don't, because the reason the fallback method is not going to be that good in this case, and you could improve it, and the reason it's not going to be good is because you have you only have a limit of 2,300 gas to process any functionality within the fallback method. So what all I'm going to simply state for the fallback method is public, it's payable, and it's simply just going to revert. So if anyone sends anything to that function, it's just going to instantly revert it, because we can't run it. We just won't have enough gas to do what we want to do. Now, obviously, you could simplify this massively, and you wouldn't have to just simply revert it. But for safety's sake, I'm just going to leave it as reverted. That will save the person's transaction fees and gas fees and everything else, and it'll just reduce load on the network. So what was the problem that we had? I'm just going to move this down here so all those sort of methods are kind of grouped together. So what was the kind of the key problems that we had here? We're stating a start and end date. Okay, so we should only be able to buy during an available period. So I'm going to create a modifier now, and I'm just going to call it is available. Now, all this is going to do is simply call to check to see if the block number is between the start and end date of the or start and end blocks of the actual constraints of the Crowdsale. So this is simply going to be require that I think it's block.number is more than or equal to start, and block.number is less than end. So it's got to be within those constraints. Now, I'm also going to chuck in another constraint for this as well to check there is actually available balance left. So I'm also going to require that the balance is more than 0. Just to ensure that we actually have a balance available to actually be able to transfer the tokens to that specific person. So again, we're not losing any unnecessary ether, and we're not costing people any extra gas or adding extra load to the network. So as I've applied to is available on the buy for, it's also applied it to the buy as well, which is good, is what we wanted. Now, the next thing that we need to address is the limit. I'm going to leave the price till last, it's a little bit more complicated. Now, we're going to have to create a mapping here, because we want to state there's a limit on how many people can buy, for instance, at this value for this period of time. So we're going to say address to a uint, and we're going to call it private, and I'm going to call it limits. Okay, so simply all that we're doing here is stating that if we need a new modifier within limit requires that limits message dot no, actually, because we can buy on behalf of someone, we also need to make this a recipient who's going to be receiving it. So limits recipient is less than the we also want to check that there's not going to be an excess as well, recipient and a uint value. So limits recipient dot add value is less than the limit, and then call the function. So we're going to require that the person receiving those tokens for those specific prices through the ICO or the crowd sale, plus the value that we're actually transacting. So for instance, it's 2 and we've already transacted 1. Obviously adding another 1 will still be within the limit. Actually, it wouldn't be unless we do it less than or equal to the limit. So that should cause that to fail if anyone tries to buy over the limit amount. So we now want to state that as one of our modifiers as well. So in this case, we want to say available limit for the beneficiary and also the message dot Would that work? That might not work out. I'd have to pass the message.value, and then I'd have to calculate the amount that I'm trying to purchase, which is the next thing I want to get to. So simply to state that the value is going to be because that's a value in way or ether. So let's create a new uint. Amount is equal to value dot divide, because it's a uint, and then the price. So that's the actual amount of tokens we're buying. So because that's a way, we're simply stating that that way value divided by the price of each of these tokens. Now it has to equal an exact amount. So for instance, in this case, we're passing 1 ether, and we're saying it's divided by the price of 1 ether. Then it obviously be the price of 1, or the amount of 1, which is what we're adding. We also need to use that functionality. We specify the amount down here. So let's just simply state that the amount to transfer is the amount, and the balance is going to be minus the balance. Okay, that should be okay with that one. I'm just checking I didn't have another condition there. Limits dot add. I forgot to update the limits. So limits, in that case, beneficiary is equal to limits beneficiary dot add amount. Now the other thing that I did have in my previous example is I had an event as well, which was simply a buy event. So we're going to need to chuck in an event. I'm going to call it buy, and it's going to be an address and amount. And then simply we're just going to state after all that works, beneficiary amount. Okay, so we now have some constraints added to our crowd sale. I'm just double checking that again, that I didn't miss anything. I did miss something there, because the value is actually message.value. And did I miss anything else? No, I think I should be okay on that front as well. Okay, so if I now run the tests again, hopefully they should still all pass, because all I've done now is just added some constraints on the sort of the limits. Just a side note with my tests, which you might actually want to implement yourselves if you're doing this, is checking that those constraints are working. Now you might not essentially want to do it as requires. Oh, well, I have made a mistake there. Cannot read property of constructor of undefined. Oh, interesting. What have I done there? So that's an interesting error. Don't think I had that one before. Cannot read property of constructor of undefined. Val.constructor is bn. Interesting. I've probably made some very basic sort of. It's probably something to do with the event. I have to. It's a little bit of real-time debugging. I actually have the whole contract here already defined. If this still plays up, I might just switch this to the actual one that I know I have working, and then try and figure out what's wrong with that later. Hopefully. Oh, you do actually have to pass names. So beneficiary and amount, and that is simply beneficiary amount. Just double check that still works. So yeah, for some reason didn't know you actually had to specify keyword identifiers for the variable parameters, but that seems to have fixed it. Let's just see. Everything passes. Good stuff. So there, in a nutshell, is how you develop a crowd sale or ICO. Pretty much going to leave the tutorial there for today. The code obviously is going to be on the GitHub repository, so if you want to play with it, use it, feel free. There is no sort of licensing around this. You are more than welcome to use it. My advice to you, though, would be to ensure that you have tested and modified and make sure that I have not made mistakes here. I make quite a few mistakes. I would not just take my code at face value and deploy it in the network and use it for something, because especially I'm not taking the backlash for that one. You've been warned, so if there is issues, you're going to have to resolve these yourselves. Now, like I say, that in a nutshell is how you do a very simple Crowdsale or ICO. I actually have about 5 other tutorials kind of lined up. This is the one I wanted to address the most. As you saw, there's quite a bit of work that went into sort of developing this and ensuring that I could sort of convey it in a testing sort of aspect, or a testing sort of scope. Which I hope you appreciate, especially with recent events highlighting the importance of testing. And I will leave the tutorial here for today. The next tutorial I'll probably be covering something to either do with the access modification of various values, such as looking at pure and view, and as well as the constant. I'll also be looking at security, optimization, and various other bits and pieces. Now, if you did find today's tutorial useful, give it a thumbs up. If you would like to keep up to date with any more of the videos I'm going to be producing in the future, hit subscribe. Hopefully I haven't made too many mistakes today and the actual code this week is visible. And until next time, good luck, and I'll see you around.